Okay, so this is just going to finish off with rotations. Kind of go back over a couple more things. Number one, that we have, that it tells us that Casey is going to walk a mapping of x plus 8y. The plus tells me that we're going to move to the right. And he's going to go 8 steps. The y is going to stay right where it is, which means the figure's not going to move up or down. So just take each point and move it over 8. And really, once you get a couple of points in, then you can just replicate him. And then it tells you that he's going to fall flat on his face. And remember, when we're talking about rotating, and we're rotating around the origin, that really what I told you is it was like just taking your paper and you could just rotate your paper 90 degrees. So this blue figure is what it should look like after it's been rotated. So I'm going to go ahead and just draw it on there so you can see that it's actually a different thing, but I'm taking it, I'm rotating it around the origin. So when he falls, he should fall right here. And that should be the same figure. Down here on the bottom, I had asked you in class to attempt to try and do these on your own, much like the notes that we had already done in class. Again, this is about the origin. And remember, we talked about 90 degrees counterclockwise. That means it's moving the opposite direction of a clock hand. So we're going to end up in quadrant 1. And that'll tell me that my point should be positive, positive when I end. So right here, all of my coordinates here should be a positive, positive. Remember, when we're rotating 90 degrees, that we can just flip our coordinates. So E is at negative 7, 7. Sorry, messed that up here. E is at negative 7, 7. So if I flip my numbers, then I just have a 7, 7. O is at negative 7, 1. If I flip my numbers, that would be a 1, 7. And then my G is at a negative 3, 9. So that means over here it would be a 9, 3. Now we're going to do it where it's not at a point. So I'm going to rotate it around the point P, or A right here. And I had taught you in class to draw a straight line to that point. So if I rotated point A, or rotated point O around point A, we're going 90 degrees clockwise. So instead of it being here, it would come straight up. The same number of units it was over. So this point right here would be my new O prime. So O prime is at negative 3, 5. I also taught you in class the mathematical way to handle that. And point O is at negative 7, 1. I said that at that point, then we could take this new point and subtract it. Negative 3, 1. So negative 7 minus a negative 3 would give me a negative 4, and 1 minus 1 gives me 0. Then I follow the same pattern up here, where I'm going to say, okay, if that's the case, then I need to flip my numbers, so it would be 0, 4. It's going to end up in the same quadrant, so that would be a negative positive number, and then I'm going to add back into it the negative 3, 1, that point. So 0 plus negative 3 is negative 3, and 4 plus 1 gives me the 5. So I ended up with the same point, just a different way to work that problem. So same thing with G. I'm going to kind of erase a few of these marks just so we don't get too cluttered. Point G right here. How do I get from A to G? Well, if I'm going to rotate that line 90 degrees clockwise, it would end up over here, the same number, 8. 8, so this point right here would be my new G prime. If I did the mathematical way, G is at negative 3, 9. I'm going to subtract the negative 3, 1. That would give me 0 and 8. Then I'm going to flip them, so it would be 8, 0. And that one would end up in this quadrant right here, which is a positive, positive. And then I would have to add back in the negative 3, 1. That would end up at 5, 1. Is that true where this ended up? 5, 1? Yes, it is. So G prime is 5, 1. And then finally for our last one is E. This is where I said you'd have to create the L's. And I'm going to rotate that around. So if I rotate this blue line right here 90 degrees, it would end up here. 1, 2, 3, 4, 5, 6 units long. And then I would rotate it to where the E would be sticking up, and that's going to be 1, 2, 3, 4 units high. So this would be my new E prime, which is at 3, 5. And mathematically, if I did E is at negative 7, 7. I'm going to subtract the negative 3, 1. Would give me a negative 4, 6. I'm going to switch my numbers to be 6, 4. My numbers need to be positive, positive. And then I have to add back in the negative 3, 1. That would give me 3, 5, which is what we got. Okay, now on the back side. Here, they're just saying which one of these would create an image where the vertex, remember that's just a point, meets at the origin, which is at 0, 0. So it wants this shape right here for one of these points to land right at the origin right here. So the first one, it says it rotates 90 degrees clockwise around U. That means that U is not going to move, and it's going to rotate 90 degrees. Well, if this line rotated 90 degrees, it would be here. And so that means that this line right here would have come down this way. So this would be my new shape. None of those points landed on the green dots. So that is not the right answer. Then it says it wanted to cross the line x equals 3. Remember, that's when we create coordinates where the x value is 3. And you could put whatever you want here. In class, I said 1, 2, and 3. So if I graphed 3, 1, 3, 2, and 3, 3, that's this line right here. So if I reflected that image over that line, it would look like this here. Well, again, none of those points landed on that green dot, so that one is not true. Then I have the line y equals 4, much like the other one. Now I want the y to be 4. I don't know what these numbers are. Again, just plug 1, 2, and 3 in. So if I graphed 1, 4, 2, 4, 3, 4, now I'm reflecting it over this line. So my shape should be right here. Again, they didn't touch that green. But then our final move is to translate to the left 2 and down 2. So if I move each point left 2 and down 2, this point would hit left 2 and down 2, left 2 and down 2, left 2 and down 2. This would be my new shape, and that point right there lands right on it. All right, the last section here, a figure has rotational symmetry. If it can be rotated less than 360 degrees, about a point would be the same as the pre-image and the image. That means when I rotate it, can I make it look exactly the same? So on, for instance, if I made a hexagon right here, and just for purposes, I'm going to go ahead and clone that one so you can see it'll sit right on top. If I can take that and rotate it and it looks exactly the same, okay, then that would be 1. Rotate it again, that would be 2. Rotate it again, that would be 3. Rotate it again, that would be 4. Rotate it again, that would be 5. So right here, that one I can rotate 5 different times, and it come back to the beginning. At that point, that is what is my order. How many times, the number of rotations that can produce the image the same as the original. So on this shape right here, this pentagon, I rotated it 5 times. Now with this shape right here, how many times can I rotate and it make the exact same thing. I can rotate it to here, that would be 1. I can rotate it here, that would be 2. And I can rotate it to here, that would be 3. So my order would be 3. And then my magnitude is just, what have I found by dividing that by 360? So what's 360 divided by 3? Would be 120. What that means is, because I have this circle, how many times can I take and rotate it? That means this right here would be 120 degrees. From here to here, that would be 120 degrees. 120 degrees. So my magnitude is 120 degrees. So then here you want to find the magnitude and the order. So this one would be 1, 2, 3, 4, 5. Order would be 5. And then the magnitude would just be 360 divided by 5. Right here, 1, 2, 3, 4. So my order would be 4. My magnitude would be 360 divided by 4. And I believe that one is 90. I don't remember this one off the top of my head. I think it's 72. This one here, how many times can I rotate it? I can't rotate it just once, but I can rotate it twice. Because if I rotated it once, then my shape would look like this. So this one only has an order of 2. So that means that my magnitude would be 360 divided by 2, which is 180. And then this one would be 1, 2, 3, 4, 5, 6. My order would be 6. And so my magnitude would be 360 divided by 6, which would leave me with 60 degrees. I have a couple more down here at the bottom. Again, my order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my order would be 16, and my magnitude would be 360 divided by 16. And then here, if I rotated, I could rotate it around, but I could only do 1, 2, 3. My order would be 3, so my magnitude would be 360 divided by 3. So this one again would be 120. I can't do each individual one on the hexagon because I have the triangle on the inside.